Thank you for the introduction. The talk is Trajectories of Fat Mass Accretion among Preterm compared to term infants during the first 6 months postnatal life. It is recommended that preterm infants achieve rates of growth and composition of weight gain for a normal fetus of the same postmenstrual age. In a recent recent review, it has been shown, however, that preemies have a higher percent fat mass, 15 to about 22%, than term infants, with 13 to 16%. And it's currently unclear whether this trend increases during the following month or whether it reflects postnatal adaptation to extrauterine life. The objective of the study is to analyze the dynamics of fat mass accretion of preterm and term infants up to 5-month corrected age, to systematically review recent publications which presents body composition of preterm and term infants. Our hypothesis is that preterm infants less than 28 weeks of gestation achieve at term age a fat mass of about 25%, which remains constant until 5-month corrected age, while term infants reach 25% of fat mass at 3 months. This was a prospective study. Data were obtained from 3 studies with 1,088 measurements of body composition. We included preterm infants, 252 infants with a gestational age on average 30 weeks. The birth weight was 1,440 grams. Babies were from the baby and preemie study and from the McMaster Peapod study. We also included term infants. 260 infants were included. The mean gestational age was 40 weeks. Birth weight 3.6 kilograms, and this data were from the baby and me study and from the Peapod study. Body composition was measured with air displacement plethysmography using the Peapod device during the first 6 months of corrected age. The trajectories of fat mass were calculated using the Gompers growth model, and the analysis was stratified for gestational age less than 28 weeks, 28 to 31 weeks, 32 to 36, and older than 36 weeks of gestation. The dynamic change of the trajectories was analyzed using the median. For term infants, the fetal curve was estimated from 25 weeks of gestation to term age based on the reference fetus from Dr. Ziegler. The statistical analysis was performed with R. Here you see an overview on the left side about percent body fat for preterm and term infants. On the y-axis is the postmenstrual age, on the x-axis is the postmenstrual age, and on the y-axis is the percent fat mass. The color coding is term infants are shown with black dots, 32 to 36 weekers in green, 28 to 31 weekers in red, and less than 28 weekers in blue. Then we calculated the median trajectories for this group of infants shown in this line here in black, green, red, and blue. The fat mass tends on average to be 25% with postmenstrual age of 50 weeks. In preterm infants, the increase of fat mass, however, was earlier. At term age, the fat mass in percent was 23.3% for 28 weekers, 22% for 28 to 31 weeker, and 16.9% for 32 to 36 weeker, and 14.5% for term infants at term age. At 40 weeks postmenstrual age, preterm infants less than 28 weeks had 22% of fat mass, and at 45 weeks the fat mass reaches a steady state of 24%. The other groups of infants had a fat mass of 24 to 26 at 50 weeks. From 50 weeks onwards, the average fat mass remained constant between 24 to 26 for all groups. We then calculated the dynamics. The dynamic of fat mass percent increase was comparable between term and preterm infants. The postnatal increase weeks of life of fat mass starts in preterm infants compared to term infants later. Preterm infants, average differences for fat mass increase is 8.8 weeks, 5.7 and 1.1 weeks. The trajectories between infants were shifted in comparison to term infants. For 28 weekers, 5.8 weeks, 4.5 weeks for 28 to 31 weeker, and 1.2 weeks for the 32 to 36 weekers. What you nicely can see here is that the trajectory curves nicely overlap by shifting through the respective age. We also looked into lean mass, and the data show that preterm infants had considerably lower lean mass at term age. However, there was a catch-up until around 70 weeks post-menstrual age, when preterm and term infants had a similar lean mass. We then performed a systematic review to analyze body composition presented in studies. We identified 112 publications using air displacement plethysmography and 28 publications using DEXA assessment. In this systematic review, at 50 weeks, the percent fat mass of preterm infants was on average between 18 to 20% and comparable with term infants. The lean mass was lower in preterm infants, however, at 55 weeks, similar compared with term infants. In conclusion, preterm infants compared with term infants have at earlier postmenstrual age an increase of percent fat mass. The kinetic of fat mass increase is similar between preterm and term infants, although these infants were born at different gestational ages. It could be hypothesized that the postnatal increase of fat mass is a physiological transition from fetal to postnatal life. This process is likely affected by thermoregulation, change in nutrition, placenta to breast milk, as well as endocrinological interaction. And we might have to propose if an infant will have a similar lean mass, a preterm infant will have a similar lean mass at term like a term infant, but has a higher fat mass compared to a term infant, then we need to target even higher weights at term age for preterm infant compared to term infants. Thank you for your attention.